the time and we can start the session. Uh, you can go. Rest of the attendees, please go to the mute. Good. Good evening, everybody. Welcome to today's webinar. Basically, the webinar is all about the inception of data sciences, the past, the present, and the future. And this particular webinar is sponsored by VaporVM, and it is my honor that I'm presenting this webinar from the platform. I really appreciate this, and I thank you, VaporVM, for giving me this opportunity. Regarding this webinar, the webinar is being recorded, and the copy will be shared through email once after 24 hours. Also, the questions will be addressed at the end of the session. So let's start our webinar. Okay, something about the presenter. My name is Adeel. I'm a senior data scientist, data science practice lead in VaporVM. Also, as far as the experience is concerned, I have more than 12 years of experience with data sciences. I've been working as a senior data architect, senior BA consultant, and engaged in a variety of the jobs. I have extended experience with data sciences, you can say. I've been managing large data warehouses. I've been doing the data migration of big stores, you can say, from on-prem and on cloud. I've been involved in some visualization tasks and all this stuff. So you can say I'm a very naive data engineer who has the hands-on on different data platforms, and who has a very well experience and practical experience with data. So I would try my level best to basically relate my experience of this vast experience with today's session, so that practically I can explain you the different areas where I can share my experience, I can share my views about the data science. So about the today's agenda, basically we are going to discuss the data and its evolution over the period of time. Similarly, in the second step, we will discuss the use cases, how the use case has transformed from business intelligence to data science, actually. Then we would go through some practical example of machine learning, and then we will discuss the other aspects. What was the future, why it is necessary, why we are adopting these sciences, when these data sciences basically emerged, what was the reason of this expansion, and what will the future that is near, and we will basically we will witness all these changes. So let's start with a very basic concept. So when we talk about the data sciences, the most important thing is to discuss the data. So why it has become so important that every corporate and every organization is basically generating a lot of data and also hiding all this data, because they have transformed this data into information, and the knowledge that they have produced over the period of time is necessary for their businesses. So in order to understand the data is nothing but the collection of facts. They can be numbers, the words, measurements, observation, even the description of things. So data is precious. Why it is precious? Because with some little context, we can transform the raw data into information. And when we present this information in a specified way, the knowledge can be extracted. And when we engage all these knowledge together, we can go for the wisdom, which is basically the next level of knowledge. So data is something that is necessary for any business, corporate, for any individual, even for any individual. Today's data is being produced at the individual level, and this individual level data is very important. So the fruits of today's information and data age that we are enjoying is because the data has become digital. And in order to understand what is the digital data, we need to understand the repository and their management. So in order to understand the evolution of data over the period of time, we have to discuss what is basically databases and what are the database management systems. So when I say database, the database is nothing but the collection of information in an organized form. And the packages and the software that basically manages all these databases are called database management systems. So when you see this particular slide, when the data became digital, it was available in the form of digital nodes. The first database that was invented was a flat file. And once these flat files invented, we were able to store this information as a central repository. Scientists developed some other models like hierarchical models, like network models, and these are nothing but the records that are linking together in the form of hierarchies and networks form. That's it. Then in mid of the 70s and 80s, scientists developed some other database management systems, which basically relate to the mathematical model, that is set theory. And these are the most popular, till to the time, the most popular RDBMS database management systems. These are the RDBMS, relational database management systems. And these are the, still today, these are considered the best operational store available for the time being. After that, some other packages were developed, that is object-oriented database management systems. However, they were not able to get that popularity because the relational database management systems were in the mainstream. They were the people were investing in this model, and they got popularity by the end of 2000. They become the mainstream databases. So in 2000, from 2000 to 2015, this is the period where basically the evolution of the data store basically happened. So by the 2000, RDBMS were the mature packages available for the operational store. However, the corporates were generating a lot of data that was not able to hold the both operation store and analytical store. So these both stores get separated. By the year 2005, that has been conceived. We have to separate both stores so that the one would cater all the analytical things and other would cater all the operational things. However, by the 2012, the corporates and by the boom of .com, the corporates were generating too much data that was not able to hold in traditional softwares. So the new packages were invented. For example, Hadoop. Hadoop was invented because of the data warehousing, because of the real-time analytics, you can say, because of the large data processing, which are not possible on the conventional store, you can say. So the new packages were invented, and today's in this world, the age in which we are living, we have different type of data stores available. RDBMS is always there. It would remain there because this is the only best suitable solution for the operational data store. And RDBMS relational database are also enjoying some non-SQL data stores. These are document DBs. And then we have the Hadoops. Hadoop basically is a file-based distributed parallel processing systems, which basically distribute your data across the multiple machines and process them in parallel way, so that the processing of big data is possible by the invention of the Hadoop. Similarly, the packages that are related to the Cube and data warehousing is still there, and they are enjoying their technology, and this technology has become mature. And these are the basically sort of data stores that are available these days. However, it is very important to mention the amount of data we have produced by this time or with the passage of time. For example, in 2012, we were able to produce, we have already produced 2700 hexabyte of data, and that is a huge data. And in this data, 80% is basically the red mark that has been shown here is basically the 80% that's unstructured data. In order to get some insight from this unstructured data, the machine generated data, that is not possible to store in conventional system. So the big data basically invented. Big data is nothing but a repository that can store the data, which is basically very large, in a large variety, in a different variety. And similarly, in 2015, the data has become 7,900 exabytes of data. That is great. I mean, this data would not be possible to store in conventional systems. And it is expected by 2020, we would be producing almost about 35,000 hexabyte of data. And that data would be available for us so that the insight can be extracted from this data. And this is not possible with a conventional system. We can do this thing. So this is basically where the emergence of the data science basically, you can say this is the emergence of data science, and the usage of data science is become popular when we think about the big data. So it is important to discuss what is basically the big data. So big data is basically, you can see is a blend of different sciences, or you can say the applied sciences. The concept is basically ask the questions and get the answer from the historic data. And we have to aid computer science technologies. We have to aid the mathematical modeling, statistical modeling, and domain knowledge. By adding all these things, we need to extract the data that is hidden within the historic data, so that the same results that has already been happened can be produced and can be predicted accurately. This is basically the concept of data science. So again, it's a blend of different sciences. It's not like the thing that we are doing in the past. What we are doing in the past was the business intelligence. So what was the business intelligence? Basically, we need to understand the business intelligence too. So business intelligence, we have a broad, basically a comparison between the business intelligence and data intelligence, data sciences. Business intelligence is all about looking backward. I mean, explore the history and apply some statistical rules and plot the graph so that we can extract what happened. Basically, the emphasis on what happened. But whereas on data science, we look forward and present values. Similarly, the action, we have the slice and dice, whereas the data science is interactive. You can interact with your algorithm, you can tune your algorithm, you can enhance your capability with your algorithm. Similarly, the expertise on the data intelligence side is basically the business user. You must be a very naive business user in order to extract the historic, in order to interact with the historic data. You must be a good naive business user. Whereas on the data sciences side, you must be a good data scientist. It means you know the mathematical rules, statistical modeling. You must understand the computer programming. You must understand the domain knowledge. Similarly, the question that we asked to the business intelligence thing is what happened? What was happened? And we can get the answers like this. However, on data sciences side, we have different answers. We have different questions. What will happen? What if this happened? So this is the difference between the business intelligence and data science. The output on the business intelligence science would be a result set. That could be a table. However, on the data sciences, it would be an answer, yes or no, for example. And similarly, application, we have the historic, and on the other side we have the future. The tools, there are many recognized and renowned tools for the business intelligence like SAP, Cognos, MicroStrategy, SSIS, SSAS, you can say. Similarly, on the data side, we have different languages, packages like Python, machine learning. Then we have R enterprise. For visualization, we have Tableau, Jupyter Notes, ClickView, and all this stuff. So a data intelligence basically is enjoying its maturity. There's nothing being invented on this side. It is already had been matured. The package has been established, and people are practicing these. And whereas on the data science concern, it is transformational. Algorithms being prepared, algorithms being tuned, algorithms being basically trained accordingly. So we need to discuss basically the life cycle of both these sciences. When we discuss the business intelligence project life cycle, it is straightforward. We have operational data store available. From that, and it could be multiple operational store. For example, an enterprise can have multiple data stores within an enterprise. ERPs, weblogs, CRM, and external data that is being pulled from the web and other sites. We need to basically integrate all this data. We have to transform all this data, and we have to load this data in some kind of staging area. From staging area, we have to apply the rules, and we have to load in some kind of the data warehouse. The data warehouse would be basically the target store from where the visualization tools will get the data and plot the data. So it's straight and it's forward, and many people which have been interacting with the data know that what is business intelligence. And basically most of the people who are visualizing the data is basically doing the business intelligence. And this is a straightforward life cycle. We have to extract the data, we have to transform the data, we have to load the data into a target repository, and then from the target repository we have to plot the data on some kind of charting. And also we can do some data mining on this. We can do the ad hoc reportings. We can do some presentation and report and dashboards. For example, the best example could be in modern age, it would be the Power BI project. It's a self-service BI tool in which you basically import all the data. You basically model all the data, you create the relationship, and based on this relationship, you just create the reports that are interactive and that can present the story that happened within a business process. So this is a simple and straight business intelligence project lifecycle. And as far as the business science project lifecycle is concerned, it's different. However, the domain knowledge would be the same. You must have the domain knowledge, whereas in the business intelligence you must have the knowledge of your business process. Whereas in the data sciences you must know basically the domain in which you are going to solve a solution. You are going to basically answering the questions. You must have the idea, you must know the domain thoroughly so that you can answer these questions correctly. So the first step would be you must have to acquire the domain knowledge. The second step, once you have acquired the domain knowledge, now you know what are the data sets that are required for this domain knowledge to answer the questions. So that the second step would be exploring the data and preparing the data. The third step would be basically selecting the model. What would be the model that would be more efficient to predict my questions basically. Then the fourth step basically you would go for training your algorithm, tuning your algorithm, and testing your algorithm, and then the final step is basically the deployment operationalization. Don't worry, we will go through all these steps in an example so you can have the better understanding of all these concepts. Let's move to the other side. Next slide. Okay, so what are the prerequisites for the data sciences? The prerequisites for the data science are basically the machine learning. You must understand, you must have the knowledge of machine learning algorithms, and you must understand what problem need to be solved by which algorithm. So the basic understanding would be the machine learning algorithms and the selection of the algorithms. Then we have the mathematical modeling. Again, the algorithm that we are going to select would have to deal with some kind of the data mathematical modeling. Then we have the statistics. Statistic like you can say probability distribution, all this stuff. You must have good knowledge of all these things. Then most important, you must know the computer programming languages. One programming language is that is high level programming language is necessary for the data science, and that would be in modern ages, that would be basically the Python, or Python would be the best language that can be used for the machine learning, because it has the mature machine learning libraries that can be used. And the most important thing is the database. You must have the knowledge of the databases, how to query the databases in SQL. If the data is in a relational store, then you have to know how to basically extract the data from the relational store. So database knowledge, the extraction and scripting is very important for the data scientists. On the other hand side, you can see basically data science is mapping on different sciences. Artificial intelligence is basically the whole umbrella, you can say, where we are basically going to train the machine that would be artificially intelligent and we can interact with, so that they can answer our question. So artificial intelligence is the main core of whole concept. Then inside the artificial intelligence, we have the machine learning that we have already discussed. And we know now what is the machine learning. Machine learning is all about to basically get the answers of the question by giving it a history, by giving algorithm a memory, so that the algorithm can refer to this memory and predict the answers accordingly. So this is the machine learning. And inside the machine learning, we have another area, that is the deep learning. And deep learning is an advanced level of machine learning, you can say. So the data science is basically mapping in all these things. Why there's an area outside of the artificial intelligence? Because the business intelligence is also a kind of the data sciences. The databases, the database management, the data management and data acquisition and its training, I mean its preparation, all these basically are inside the data sciences. So the tools, let's discuss the tools. What are the tools for the data sciences? What are the tools basically required to become a data scientist? You must have the knowledge of all these tools. Otherwise, you would not say that data science tool repository is complete. So first, we have the machine learning. The tools that are being used are Spark, ML libraries, Azure ML Studio tools. They're wonderful tool. Both are wonderful tool. Azure machine learning tool is very interactive. I've personally used this tool, and it's been evolving with the period of time. Then we have data analysis. Data analysis can be done in Excel, MATLAB, in Jupyter Notes. Data analysis can also be done through any kind of the relational store. If you are good enough with query languages, all this stuff. Then we have data warehousing. Data warehousing is basically is a kind of repository which is almost operational repository, but it is structured in a way so that the reporting or the executive reporting can be executed. So what are the important the data warehousing tool these days? The people are using basically Redshift. Redshift tool, that is a columnar database store, that is MPP, excellent tool. Informatica Trend, these are the data warehousing tool that can be utilized for machine learning solutions. Then we have data visualization. Data visualization, we can use the Jupyter, we can use Tableau, we can use Cognos, raw tools, and etc. All these tools basically can be used. So we have learned a lot, but the crux of the machine learning is basically the algorithms that we interact with and that we train basically. So we have different multiple basic, you can say, the most known machine learning algorithms that we must know in order to understand the whole machine learning and you can say the data sciences. So we have two types of algorithms. That is, one is supervised learning algorithms, and second is unsupervised learning algorithms. We have two classes. In supervised learning algorithms, we have two classes, two broad classes. That's classification and regression. So the classification is basically nothing but to predict the class accurately by training our model, by giving the memory so that the class can be predicted accordingly for the new cases. Similarly, regression is a mathematical formula that is basically based on x and y axis. We have to predict the y axis once we tune our x-axis. This is how the regression is regression modeling basically regression modeling is basically done. It is a dependency. It is a formula dependency. We have to devise so that the dependent variables can be extracted and predicted accordingly. Similarly, we have another model that is unsupervised model, which we cannot tune, which we cannot prepare, which we cannot, prepare, is basically clustering. The clustering model is the type of the algorithm, or you can say are the models which basically tune itself, train itself. It basically create the small cluster inside the big clusters and relate these clusters and do some kind of relationship between these clusters, so that in a big cluster where we can identify the small cluster and the relation. For learning and for understanding some particular cases like classification, we have devised basically an example for you so that we can understand how basically machine learning algorithms train and what is the project, how the solutions can be devised for a machine learning you can say a machine learning solution. We have selected the classification example. So the machine learning overview, this particular session is all about to discuss the problem, the solution, and the selection of the algorithm, all this stuff. As I have already shown you the life cycle of machine learning. So the first step is to understand the business. For example, I have a broad example. I have a very common example. Determine the salary range of a specific person. Now, for answering this question, this specific question, I have to devise other questions, and I have to interact with the business for particular business. So what would be these questions could possible? These questions would be: what factor affects the salary? That is the main question I would ask, and then I would gather all the attributes that affects the salary. So does age affect salary? Yes. Does age affect salary? Similarly, does education affect salary? Yes, education affects salary. And does smoking affect salary? No, I don't think smoking. So in this way, we question our business, and we get the relevant information, and we basically prepare this information so the predictive model can be selected and be trained accordingly. So the next step would be basically prepare the data. Once I know the relevant questions and answers, and based on these attributes, I can filter my fields. For example, here, I know this marital status is not required as far as the salary is concerned, so it is not relevant with my information. Similarly, race is not required, so I have to remove this information because this is not relevant with my problem. Similarly, my sector, and then education number. These are the following fields which are not required. So I can remove all these fields, and then I need to filter all the data that is basically, for example, if the age column is empty, it's then this candidate record would not be, it is not possible to answer this candidate record because the age is a dependent variable. Similarly, if education is empty, education is a dependent variable. So we have to get rid of all these things, and we have to clean the data so that a final data can be prepared which is able to be trained. So on the right hand side, you can see we have created a relevant data that that we can train, and that is clean and that is relevant. So that next step would be to basically train the data. We have already selected the algorithm that would be a classification algorithm. So now we have to train this classification algorithm. The thumb rule is to divide the data that has been selected into 80-20 ratio. 80% data would be trained, would be labelized, you can say. Once the data would be prepared, the rest of the 20 data would be basically executed and evaluated on this data. Once the algorithm memory is trained, so that evaluation can be done accordingly, and based on these evaluation, we will tune our basically algorithm. If the accuracy of the algorithm is above to an optimal level, then we can release the algorithm into the production, you can say. For example, in this slide, you can see the 80% of the data was trained. 80% of the data was trained, and the rest of the 20% of data was evaluated on this training. So optimization and tuning is basically the main course of data sciences. Once we are done with this, we evaluate our prediction. Evaluation is very simple. For example, if we have 100 records that need to be evaluated over some kind of algorithm for this predictive analysis, then if it returns 80% records, then it means our accuracy is 80%. And if it returns 90%, that means 90% true valuation. That means our accuracy is 90%. So based on these accuracy, we basically finalize a model. The optimal level would be in between 95 to 100. You can say it's not possible to have 100, but 95% accuracy would be excellent accuracy in machine learning. So if the accuracy is acceptable, the model is deployed. An example of deployment may be setting up an API which accepts the feature as arguments and return the target labels. This is how basically the machine learning algorithms trained, evaluated, and deployed. So what could be the other cases? Machine learning have multiple use cases. For example, predicting the best retail location. We can do this thing if, for example, if we are collecting the social media data, and in a particular social media data, we can identify the location where the people usually go and do the shopping a lot, so that by using these models, we can predict the best retail location for our future business, you can say. Similarly, predicting why patients being readmitted, by referring the same cases to the historic patients, we can predict why the patients basically being readmitted. Similarly, detecting insurance frauds. It could be real time. It is possible to detect these insurance fraud real time. And also in gaming, the most of the houses, the gaming production houses are embedding the AI and machine learning within the game, so that the game train himself with the passage of time, and can utilize the skills that the advanced player have. Similarly, the image, speech, and character recognition are the areas. These are the cognitive sciences which can be used for the machine learning, and especially the energy management. These are the different areas where machine learning can be used. And then, what is the future? The most important question: where we are heading? Because we are producing the zillions of data, which is large in amount, which is impossible to explore by any human eye, or you can say any human being. So what would be the future? The future would be AI would enable to explore these large amount of data and extract the relevant data and do the machine learning, all these things. Similarly, the data exploration, same. If Facebook has 4 million likes per minute, then we can gather the sentiments of the social elements, so that the decision can be taken at real time. And this is only possible with the AI and machine learning. Also, machine learning, as already discussed, is now already been enabled in gaming, and games are being trained themselves, so that they can compete the players. And similarly, the data science is available for you can say development deployments. Machine learning can be used. The same kind of deployment can be reused and can be referred to the history, and so that the same algorithms, the same things can be utilized and can be used with the data sciences, you can say. And also, the very important thing, every country is looking for the safe cities. And without AI and machine learning, safe city projects are not possible. They are being used in safe cities, and all the advanced countries are making these safe cities, or you can say these smart cities, and they are all based on artificial intelligence and machine learning. And risk management is another area where AI-powered financial decisions are there, so that the financial decisions at a prompt time can be established and can be executed. Similarly, the robots are being used, artificial intelligence is being used in agriculture and all this stuff. So this is basically the session is all about basically give you the concept. What was the data science? What is the data science? What was the history of data? How the data was evolved over the period of time, and where we are going. And this session is all about what the foundational concepts. And I hope you have acquired basically the foundational concepts. If it is required to, take data science as a career, it would be a good beginning. So we have question sessions now. If anybody has any questions, please ask. I would be there for the 15 minutes to answer these questions. Yes, if anybody has any question, please let me know. You can unmute, please. Also, if you can text me, you can text me.
Yeah, so I have a question. Can you hear me?
Yes, yes, go ahead.
Yeah, so you mentioned that to become a data scientist, you should know one programming language, high-level language. Um, and you mentioned Python as a go-to language. I don't know Python, but I know Java and .NET. Um, do you think it would help me further on, or would I have to shift to Python? Are there libraries available in Java?
Yes, it all depends. If the libraries for the machine learning libraries available in Java, you can use Java. I said you can use any machine high level language that has the matured machine learning libraries. You can utilize them and you can ask the question from these libraries. So if you are good enough with Java, then you have to explore if Java has any kind of the machine learning libraries. Then Java would be can be utilized for the machine learning training and all this stuff. Similarly, other languages, if you have.
Okay, great.
Hello, I just listened to your session. It was quite informational. I just had a question that being a business major and having a specialization in particularly in marketing, do you think that transitioning from a business degree to let's say a field of data sciences, would that be in my interest a good career?
Yes, good question. The question is basically if you are a business expert, if if you're a business graduate, is it possible to utilize the machine learning algorithms to predict the future? Yes. For actually, the machine learning or the data science is a blend of sciences. I've already discussed this thing in detail that it is all about the domain expertise. A business user can have the domain expertise. Similarly, you must have the good skills of programming. So similarly, you must know the mathematical modeling and statistical modeling. So I would recommend if anybody wants to become a data scientist, he must have fundamentals or foundational knowledge of all these things. Oh, but with the passage of time, you would learn all these things. Once you would start enjoying this data science game, you would learn it yourself. The answer is straight. You have to learn because without these, I mean, mathematical and statistical modeling and also the programming languages, you would always be dependent on the others. And if you want to do all these solutions, all these things yourself, then you have to learn. Otherwise, you can be a business expert, or you can be part of the team. You can basically giving the solution to any BI problem, or you can say data science problem.
Okay, thank you so much.
No issue. Thank you. Anybody, please?
Yeah, so I wanted to ask, how long does it take to give a typical data science solution, can I do it in a month or a few weeks? How long would it take me to develop a good solution?
Yes, the good question. Again, you must have the similarly. You must, if you have the domain knowledge, you can acquire the data, and then if you have acquired the data, relevant data, you can train your selection of algorithm would be more easy once you have the question in hand. So typically, machine learning or a data science project should need to be should need to be take almost about 4 weeks. In 1 week, you would basically you would get your required data, you would get your questions, and the other week you would basically acquire your you can say the models that you are going to use. Then you will train your data, and then you will evaluate your model, and then it will be deployment. So a 4 week job would be more than sufficient in order to acquire in order to accomplish a data science solution, you can say. Let me know if you have any question. Otherwise, we are going to end the session.
Adeel bhai, can you hear me?
Yes.
Okay, fine. I have a question. How can we basically pitch business intelligence as a service in Pakistan to the Pakistani customers?
Yes, it's very important. If we know the pain areas as far as decision making is concerned, then it is very then it would be very easy to pitch the client. For example, in Pakistan, we have retailers that want to know what would be their predictive sales in the next month. These are the cases. If the different kind of retailers want to know, then they can refer to the data sciences. They can refer to the data sciences team. And similarly, if they want the analysis, something like market basket analysis, data mining solutions, and all this stuff, they can refer to us. So we need to know what is their pain area, what they want to extract from their data. If they are generating their data, then we have to know what they want to extract from this information. If they're generating a lot of information, then this information need to be utilized accordingly so that the predictive analysis can be possible. And any business have some always have a room for predictive analysis. As an example, everybody want to know what would be the sale of this particular store in the next month based on the historic data. And similarly, everybody know what are those products that would not be required to be purchased in the next month. That is another area we can go for this thing. Similarly, in large infrastructures where a lot of resources are working together, we can create a predictive model in which we can see what are the resources that would be dead by the period of time. We need to replace all these resources. That is another area where we can utilize area. We can refer to the historic data so that we can predict the future of their infrastructure model. So there are different areas we need to explore the different businesses, and every business basically generating a lot of data which can be referred as a historic model so that the prediction is possible. You need to think like this. If somebody is producing a data that is relevant for their future business, so we can predict that future for them. I hope you understand this answer.
Fine. Do we have any demo that we can share with our customer so that he can understand what we can do for him?
Yes, sure. we have prepared some demos for Gourmet Pakistan, and that can be utilized for the other clients, for the retail clients, in which we have modeled the data for the predictive analysis. And similarly, we can devise other solutions. For example, the network-based solutions and retail models, solutions. We can devise all these things. For the time being, we have retail models available that can be utilized. Yes.
Fine, thank you.
Welcome. So basically, that is the end of the session webinar. I again appreciate VaporVM. It is my honor that I'm presenting this webinar from the platform, and I hope that we will meet soon with the other session, with the other informative session. So that is all from my side. Thank you very much.
Thank you, sir.
Thank you.